Hello and welcome to today's special Ultimate Tech Challenge episode of Thursday Tech Bites. I'm Rick Vanover, and we are going to talk about resiliency. And we've got like a transatlantic situation. I am in Barcelona, Spain at an industry event, and my guest today is coming to us from AWS reInvent in Las Vegas. I'd like to introduce Rob Girard from VAST Data. Good afternoon, good day, actually good morning for you, Rob. How are you?
It's good morning for me. I'm good, thank you. How are you, Rick?
Hey, I'm doing great. We've been talking about this episode for a long time. Like I said, I'm in Spain. You're in Nevada. Our producers are in Ohio and in Georgia in the US. Let us know, everyone, where you're from. We are live on 4 platforms simultaneously, and I've got it up right here. So if I mistype anything with some of the responses, that's just because it's truly live. This is going to be a fun episode, Rob. But before we get going in, do a do a quick intro. Where are you from? What do you do at VAST?
Sure. So I've been at VAST Data for over a couple of years now, and I've recently moved into the office of the CTO as a field CTO for virtualization and data protection. Now, VAST Data, if you're not aware of it, is a data platform company, and we're best known for where we got our start, which is purely in storage, very large scalable storage for like HPC workloads, and for our main use cases come into like AI, like feed those GPUs with massively parallel access to all flash holding single tens, hundreds of petabytes in a single massively deduped cluster. Very fast, very scalable, and we can scale our performance capacity independently in our cluster. The other use case we have is around big data and data analytics, like Hadoop replacement type of things with big data lakes using S3. And we are a multi-protocol platform, and we've got S3 and SMB and NFS, and we've just added some database functionality to that too in the summer. I want to drill into that, but it's not super applicable in the data protection use space. And the third use case we have at VAST is data protection, which seems like the odd duck. So wait a second, are you saying that your
Hey,
secondary storage is like a supercomputer storage? And yes, so we tried to bring the economics down so that you can have a massive all-flash ocean of data in a composable cloud to break up into tenants, get all of the dedupe in there, and our clusters can grow. I think the theoretical limit is currently 4 exabytes. And while we haven't had anyone with a single cluster written data to that size, we do have clusters out there that are triple digit petabytes, so north of 300 petabytes of data written with data reductions in around 1.3 to 1.5 to 1. And those aren't really data protection workloads, those reductions, but that's getting like 75 petabytes for free, which is pretty awesome, right?
yeah. So a couple of things to unpack there, Rob. And so I've had Howard Marks on from VAST before, and when him and I were prepping for that, I took away VAST as fast. What I've learned here from you is also that there's a lot of really new cutting edge performance use cases, and especially some of the new stuff that's really attractive. And you, along with a lot of my Veeam colleagues, are at AWS reInvent in Las Vegas. And as you can see, we're both in hotels. We're both rigging up studios on the road. And for those of you watching, that's really hard to do, by the way. How was reInvent been for you and for Vast, and how's the event been?
So this is my first reInvent personally, and this is also VAST's first reInvent. And up until this year, we didn't have much reason to be at reInvent because we were an on-prem solution. We had built everything that way. However, that's no longer the case. We know that everybody wants multi-cloud, right? And we're enabling that and moving data around super efficiently. So actually 2 days ago, I was in your booth, in the Veeam booth. Your marketing folks have done a bang-up job. Your booth looks awesome as always. And so I got to have a little talk and present. And I tried to keep it really short because I knew everyone was just waiting for their token to put in the claw machine and see what they win.
Or the
But the one thing
seats
I
are
showed,
good. That's why I go there. Hey, I can sit down and take a break.
like, totally, but you also don't want to be trapped there because the guy's in
Yeah.
front of you rambling on and on and on, which is what I tend to do. So I just went about 5 minutes. That was it. And instead of giving much description of VAST, I pointed over to our booth, which was, you know, 100 feet away and about 10,000 people between those two
Hmm.
booths because the show floor is absolutely crazy packed. Biggest show I've ever seen. Like it is just amazing. So I went over and said, hey, if you want that. So the trick I wanted to show was around versatility of VAST and new tricks to add in your bag when you're doing recovery. And this comes back to our topic around hedging your bets to make sure that your recovery is going to be successful and we're going to be on the winning side every time.
Yeah, so everyone, no joke. Right before we went online, I went on Twitter, X, the platform, and for those of you watching, thank you for that. And again, let us know in the comments where you're from. Big shout out to Luis from Cape Town. Welcome. I'm looking at this. Live is live. But one of the things we did right before the start of this is we did a resiliency test. Rob, no joke. What was it, 86 or 87? You kicked off an instant restore.
Well, if we can share my screen, if we can
Yeah,
show
let's
that,
move over to the lab. We're all
I'll
demo
move over
here
to
on this
Veeam
one.
here.
Yeah.
So bear with me, everyone. There's a few things going on that are technically challenging in this. So I am going absolutely live. Um, and my connection in and out is up and down, and I think all of Vegas is struggling to keep the bits flowing in and out. So hopefully my audio and stuff's coming in. And also, I'm in a lab that we have a lot of people doing lots of stuff. So I'm actually connected through San Jose and then over through Phoenix to get to this lab. So right now there's 80 entire VM restores going on, and these are a mix of a bunch of stuff. And these ones down the bottom, I went with some that have synthetic. Others are real VMs that we use in the lab for doing different stuff. Um, at VAST, we test all of the data protection platforms, and that's why you see some of these VM names with some competitors to Veeam. But you know, I'm here because like this is really the GOAT. When we put these together, this is really awesome. I love that Veeam is the innovator on the instant recovery. That had me hooked as a customer when I first bought Veeam in 2011. So I do have hands-on with Veeam on the customer side first for over a decade. And one of the things I love about instant recovery is being able to just turn things on. But the problem is if you can't get your data out of your repo fast enough, then it's not going to really work all that great. And so with a nice all flash backend, sure, that's there. And now if you heard my intro about storage for supercomputers, you're like, yeah, I don't think that's going to fit my budget. And I'd like to propose that on a 10-year TCO, not only is it going to fit your budget, it's going to come in under just about any hard disk solution you can find out there. And we can drill into that maybe in another one. I want to keep this pretty technical on what we're doing here. So I did kick off these restores all at 8:52, and it's 9:09. So just for time zone difference. So we're now what is it, 17 minutes
17
into it. The
minutes
first
in.
two or
Yeah.
three don't even count because things are still kind of getting sorted out and ready. And so those are running right now. If I just look at success, so it was 86, and I look at one of the first ones here, and the statistics on it, this one had a restore rate of 2 gigabytes per second. And that's big B bytes, not little bits, right? And so let's just go over to these running ones. And what I'm doing is actually my favorite trick on VAST. So let's just back up a little bit. And ransomware is obviously a very hot topic, right? And it has changed the nature of restores. So where it used to be, restoring because you lost, hardware or there was an incident or user error, onesie, twosie kinds of stuff, right? But today, you're slowly getting all of your infrastructure encrypted underneath you. Um, and you can still access the encrypted data and not notice it because the keys are granted to you for like a 60-day trial. 60 days goes up, the trigger hits, and you don't get the keys to your encrypted data anymore. So it's silently encrypted all over. And so now if you're not holding enough data, you're not going to be able to find where that data was still good. So when we do the restores, we can use things like instant recovery. inside Veeam to fire up and see, is this good, yes or no? Now, we can also leverage a lot of the Veeam 1 tools to see those inflection points of when the backup sizes change. So we have a good idea of all of a sudden we got a lot more data change. So therefore, that's probably when the encryption started. But we can then go through and we have to restore it somewhere. So we know that we need to pull a massive restore out of lots of stuff. But then my challenge to everybody, and the thing that I want to talk to customers, everybody's forgetting the most important thing, or maybe it's not the most, but it's very, very important, is that yes, you got to read fast from it, but you got to write fast somewhere, and you got to have somewhere to write to, and then that where you are putting it has to be production grade so that you can actually run your infrastructure off it. So can you restore that back to your production storage? Because I would propose there's 4 places you could restore to: production storage. Now, in the case of ransomware, you're out of space, and I've yet to meet an admin that I think this is ransomware. Let's wipe all of our production arrays and make room for restore. Nobody ever, right? So the other thing too is for compliance reason and legal, you could have police actually put some red tape up around your array, especially if it's a state level attack, right? And then you do some forensics. So that is now out of the picture. So we have 3 other options. The next one is we're going to get Amazon to drone drop us some enterprise infrastructure in like 4 hours. So, we'll just buy hardware when we need it. But that doesn't exist. And if you look at supply chains today, you're not getting fast turnaround on the kind of gear that you need when you need it. So let's just take that option off. You could actually have it sitting on standby, very, very expensive option to do that. And I've talked to customers that do have clean rooms, ready rooms, cyber vaults that have some standby stuff in addition to what they're doing with their DR for multiple sites. And then, so I think that we just take that one off the table because economic something you're not going to order on the fly. The next one is cloud. Now, cloud would be a great place to restore to. If you're backing cloud stuff up, certainly restore it there. But if you're backing up your VMware stuff, and your hope is that you are going to turn your AWS cloud account into your network that took years and years to build and customize and tweak with all the various nuances of it, it's probably not very realistic. Now, if you're very strong and have a great position on multi-cloud, maybe you can. Maybe it's very seamless between these. But I've yet to talk to customers that are at that level of sophistication where there is really kind of no lines. It's all blurred where's on cloud and on-prem. And if the lines were blurred, if something happened to one of those, then it's kind of herky-jerky. It doesn't really play out that way. And then that last one is always been a preferred one, which is like, well, just leave the data in the backup repo and run instant recovery, live recovery. And while that is great for a few VMs, you'll quickly bottleneck on your vMount servers that are serving that up, right? And you won't be able to do it at a massive scale of all of your infrastructure. Now, I recognize that these 86 VMs that I'm restoring are not a massive scale, but it does represent, I think, about 15 to 20 terabytes of written real data, not just the disks were provisioned that size. And so these have been restoring now. So we
Yeah,
get off. How many minutes ago?
Couple things here, Rob. First of all, I actually thought I read it wrong. We're doing full restores. That's the whole IO set being put back. It's not the instant recovery, which is that high-speed recovery technique, like you said. We can do several. I mean, 10, 15, 20, not a problem. But you're moving a lot of data here on the full image recovery, which is really, really attractive. That's cool.
So where I'm moving it to is even cooler. Because I'm choosing option number 5. Like, I thought there were 4 options. No. We've got option number 5 as well, which is, what if your repo had lots of horsepower, had multi-protocol, and why do you need multi-protocol? I'm like, I focus all our backup on S3 objects. Veeam's focus is writing in object. That's where we get our immutability support with S3 object lock and compliance mode, fully supported on VAST. And so then what do you need the NFS for anymore if I'm no longer doing a V11 sober performance tier and capacity tier S3? Well, if I want to run some VMware data stores out of this same box, which I do, And we're on the HCL for vSphere. So we've got customers running like, huge production VMware stuff off of these same VAST clusters, not the ones we're backing up to. Super clear. Just full disclaimer, I am not promoting getting amazing dedupe of prod and backup in the same box, but I am promoting leveraging amazing data reduction and dedupe to write the restore into the same box for near free capacity. And when I say near free, we're talking about a 98% reduction when I compare the format of the Veeam native objects, which we usually recommend a 4 or 8 meg object size, because where that might give you a capacity penalty in the cloud, on VAST with all of our data reduction and everything else, it's not only not going to give you that, but it means fewer HTTPS calls, so more payload and fewer session handles, right?
And this is object storage. Just double checked. We're writing this to object storage for these backups. It's not a NAS block protocol. Just making sure.
So we're writing into NAS and we're reading from S3. And I can show you that actually.
Oh, that right. Like. So got it. Yeah, let's take a look at the IO visualizer, or what is this razzle dazzle thing that you have?
Well, so just on the vSphere side, here's my storage DRS client. I've got 4 underlying data stores, and I'm connecting them in an interesting way where I'm connecting them to the device backing here. I've got this name here, fully qualified in vSphere-1 at my VAST cluster at my domain. And then this is vSphere 2, 3, 4. Now, by doing that, I'm getting a whole variety of IPs because VMware locks on an NFS data store IP and doesn't let go until pretty much till you reboot it. And I want to get some good diversity going on. And by diversity, what I mean by that is, we'll go back to the VAST UI. And apologies if I'm jumping around. It's been a pretty crazy week here at the show. It's also early for me. But here we have the flows going on. And down in the bottom, I want you to look at this bottom left corner. This is my throughput, and I have some read and write bandwidth going through. So this is reading and writing around 4 gigabytes per second at the moment. That's big B, right? And so total bandwidth in and out around here is we're pushing 8 gigabytes per second. And then you're like, okay, well, what is that flow? What's the work that's happening? So we can go into our data flows over here. And now bear with me because I've been having some latency issues here, but so far demo gods are being kind. Thank you very much. And what I've got is the flow of what's happening in the moment. Now, this is a proportional bar to say that we're split about half and half. Now, this is a lot to take in. So let me just start out by drawing a line right here, right around the 40% from the left line. This is a line. Everything to the right of it is the VAST cluster, and everything to the left is the network, the client network. These are hosts. These are the IPs that are having activity with the cluster. These are user IDs. Now, if I was using this for home directories and user NAS and stuff, this list would be massive, 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 massive,
sure.
Right? All the different users. But in this case, I have this one user here called Veeam Ready. This is an AD account that we've connected with, and then mapped it to some S3 credentials. We put an access key secret key on that inside VAST. That access key secret key doesn't actually push into the Active Directory, but it lets us leverage Active Directory so we don't have to go start recreating accounts. We say, hey, here's the account that we're already connected to in our directory. Enable it for S3, and it'll spit out access key secret key, show you that key one time, and then never show it to you again. But you can always add more keys to it and delete them off it, so you can rotate and roll out, even though you can't recover what that secret was. And this one in particular, and I know this is hard to see, and I'm not sophisticated enough to do some good zoom in stuff, but we're looking at, we're reading off of this around 3 gigabytes per second. Now, let me just click on here, and I'm going to isolate this flow. And so this is that user, and there are 4 systems that are in use. Any guess to what these systems are, Rick?
Would they be a Veeam backup proxy? Is that the winner?
Ding, 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 ding. Gold star, buddy. That's right. So We are, I've got four bare metal proxies in play right now that have 50 or 100 gig networking each. These are those front end IPs. So in Veeam, I configured one simple repo with a single line, no sober with a bunch of extents to balance buckets or anything like that. One bucket, there is no limits essentially to what we can put in that. And as we expand a VAST cluster, it just gets bigger and bigger. We just keep putting stuff in that same bucket, and we'll just spread it over the cluster into
Speaking
many petabytes.
Speaking of bigger and bigger and spreading all over, I just got an update from the producers that the map is ready. I want to take a look at that real quick because we've got people joining from all over, but I know there's a bunch of you I can see. Where are you tuning in from? We've got Nebraska, Ohio, Georgia, Nevada. There's got to be more in the US. Let us know what state. Give me Canada at least. Make the whole top green. And then down south in South America, we have, we'll do Europe. We've got UK and Spain, and that's me in Spain. And then in, let's see, South America, we've got Chile and Brazil. There we go, a big swath of green. Over in Africa, I thought I saw, or there it is. We have South Africa and, oh, Shiza, I lost the other one. And the other country is Kenya. So sorry about that. But yeah, thank you all for tuning in. Let us know. Oh, we got another one from South Africa. No, I'll give you a like for that. But you thanked the lab people too early, Rob. Let's see
No,
if that
actually, it didn't. Your
reconnects.
timing and going to the map was spectacular because I think I'm about
I
to come
swear,
back and get this.
friends, I that was not planned at all, but it was a very good segue. But Rob, you're putting this environment under some work here. That's moving a lot of data, and
So we've got a
yeah.
lot of stuff in these labs, and I think what's happening is I'm VPN'd into San Jose, and then we're going across like a gig link between the two, San Jose to Phoenix, where this lab is. Everything's local in it that I'm doing. However, I think my spidey senses are tingling that the timing of this is probably a replication job of some other labs pushing things in and out and saturating that 1 gig link, and I think that's actually what's impacting me. But
No worries.
what I did in the meantime was I zeroed in on the other user instead, right? Which was that root user, and this is NFS protocol. Now I can filter and say, hey, how much of this is S3? How much of it's NFS? How much of this is SMB, right? I can see all of these things in the flow, and we've got the four top views. These are NFS exports that are being written into are these 1, 2, 3, 4 locations, and we're writing into them. That one's being written at 500 and whatever megabytes per second. This one's coming in at gigabyte per second, etc. And those represent, oops, here it's kind of blipped on me again. When this comes back on the vSphere side, we'll show the storage DRS cluster had those four. So we are reading and writing the same data store, but more significantly, and this is a local activity, right before we started and we kicked off our job, this was at 8:45, and I kicked the job off, I think 8:52 was when I said go, which
Right.
is now 8.
It's 23
So,
after. Yeah.
so 28 minutes ago, I think, or something like
So you're
that.
about 31 minutes into the job.
And so what I would like to see is how much data did I just restore back to it in terms of logical, right? That's interesting to me. And then more important, how much space did it actually use? And I am telling everyone
Yeah.
that it's free space because we already have the data there. Yes, it's completely different format in objects, in Veeam's format, and most, maybe all, other platforms cannot dedupe like this because they don't have this byte granular dedupe that we do. We have three different methods of data reduction, compression, and inside of that, we've got filtering to do different compression types. We just sample the data and choose what's best. We have dedupe, and we're byte granular with something called adaptive chunking. And so what we're doing is looking for signatures in the data that are like. So instead of cutting at arbitrary offsets at say 32K or a variable dedupe, which might be like 4 or 5, a dozen sizes of chunks to cut it at, still kind of arbitrary. We've got over 50,000 chunk sizes between 16K and 64K. And so what we're doing is we're pre-processing the data to cut it so that it's naturally predisposed to dedupe very, very well, because we're just looking for like, a same marker, nothing to do with previous data, but just always cut it there. And then we've got VAST similarity, which is a proprietary technology that works off like weak hashes and hash collisions to take advantage of that, to then find partial matches in blocks and still do dedupe. So I realized that time-wise, we've got 4 or 5 minutes left. Let's see where we're at. We were at about, let's just call this 440. I'll say terabytes, even though it says TB bytes. I got it in base 2, so it actually matches the rest. And then this one, let's just call it 100 terabytes. And
Okay.
we'll come back to
what are we at now after all that data we've moved, though? That's the question.
Let's see. I am not sure. I don't even know how much data was in those VMs that I selected. So
okay,
I'll find out after. There's other ways I can find out they were. And I'm just going to go into my dashboard. Oh, I think I'm going to see a remote connection timeout in a second. So just bear with me.
Yeah, no worries. Live is live, friends. Doing this, like we say, right from hotel internet, from other things going on in shared environments. It is tough to do these things live, but Rob was up to the challenge, so I appreciate that. Rob, I do want to cover up a few things here real quick.
Here it is. Yeah, this is important to get in here. 446.5. So 6.5 terabytes have been restored so far. And we've taken 230 gigs to do that. And if I do the math on that, I believe that's going to be I think a 97% reduction, 98 to 90. So that means that the overlap is so good between storing it in an object. We logically just wrote it in. Yes, there's my timer saying we're just about out. We put it in, and so let's just pretend that we had 2 petabytes of front end that we're protecting, and we bring it back, store it in object, and we get a 4-to-1 data reduction. So we only take 500 terabytes usable for that. And let's say that our cluster is total 600 terabytes. So I have 100 usable terabytes free, not logical. And then you're like, wait a second, are you telling me you're going to look at that 100 terabytes free and you're going to attempt to write 2 petabytes into it? Absolutely, I am. And the reason I'm going to be able to do that is because the data is already there, just in a different format. Now, I'm not going to do it super efficient where I've just transferred the format magically. We're not there yet. We're just wait till where we're going. But I am going to read it through these proxies, write it back in. As far as Veeam knows, that repo and the destination have nothing to do with one another. And our VMs are restoring. And if we go back to Veeam, we'll be able to see how many are left out of those. So we've got some that went. Some of these ones are bigger. These are about a terabyte each of written data. So we've got just over a terabyte. I've got, I think, 20 of those. So these are all kind of running through. And if we go back on our success, we can look at some of these ones here. Fail test win, for example, is sitting at 326 megabytes per second, but the concurrency on this was pretty huge. We're doing many restores at the same time here. You can see there many are in process. My proxies are limited.
Well, it's going down. I mean, they're finishing.
Each.
Yeah, the other ones are finishing, so it's making progress. I did get a question here for you, Rob, from Raghavan. Asks, sorry if I messed up the name in LinkedIn. How resilient is the VAST storage system when it comes to fault tolerance from an infrastructure and node perspective?
So Howard Marks, who you're speaking with, has done an excellent write-up on this. And if you go to our website, you'll be able to find it. But it's I can't remember if it's 8 or 9 nines of resiliency. So we have really wide stripes against these disks. So the smallest cluster would have a 36+4. So that's only a 15% parity overhead. And that's one of the ways we can get this flash down cheap. We can lose 4 disks in that. And when we lose one of those disks, we automatically start to rebuild. Our erasure coding is such that we only need to read from 25% of the survivors to rebuild it. All of it's flash, so we're doing it fast anyway. So as soon as that's done and rebuilt, we can still tolerate 4 drives failing, even though one failed and we haven't replaced it yet. So the capacity drops. Then the drive arrives on site, right? 4-hour turnaround on these drives. Pull the thing out, put the new one in, and now our capacity is back to. So at any point in time, we can lose up to 4 drives simultaneously. So remarkably resilient. Now on our architecture, which I don't have time to get into because that is a massive talk in and of itself, our front end container nodes that are doing all these protocols and stuff, we can lose all of them except one and have 100% data availability from the data that's stored in those massive boxes of flash in the background.
Wow. Hey, Rob, this is fantastic stuff. I love the combination of performance, next generation storage efficiency. I don't even know if dedupe is enough of a word. Some of the things you're doing here are truly incredible. Performance, the cost of ownership, the resiliency, definitely awesome in today's hybrid cloud data platform world. We do have to wrap up. We are running overtime on today's show. So a couple things I want to bring your attention to. Next week, I'm taking over both streams. I've got, let's see, on Tuesday, we are doing a zero trust approach with Veeam backup data. Don't want to miss that. And then on Thursday, the Veeam 100 show, creating a data bunker. That might get your attention. That sounds pretty interesting as well. All right, I want to thank my producers, and now I think it's time for my internet to give me the glitches as well, guys. Rob, hey, thank you so much for being with us here today on Thursday Tech Bites.
Rick, thanks for having me, and thanks for everyone for tuning in. Happy to take any questions. Connect with me on LinkedIn, and we'll go deeper.
Outstanding. All right, everyone. Thank you again to our producers and to the demo gods, the internet. We pulled it off, but we'll see you next week on the streams.
In 2023, innovation fueled every industry, from renewable energy to space travel, all powered by data. The world runs on data. It's worth more than oil, and inherent value brings inherent risk. Natural disasters, accidents, and ransomware attacks are increasingly prevalent. Years of globally impactful work can be erased. Resilient. We give you the power to restore any workload, anywhere, anytime, instantly, so you can meet every challenge head on. There's a reason over 80% of Fortune 500 companies work with us. We provide comprehensive recovery with tailored solutions that scale with you. When you partner with a global leader in data protection and ransomware recovery, you can bounce forward. Veeam. Radical resilience starts here.